Welcome to our online lecture of A-level chemistry. Today, we will talk about calculations involving gas volumes. In this episode, we will cover using the molar gas volume and stoichiometry. These are the last part for chapter on moles and equation. Let us begin. In 1811, the Italian scientist Avogadro suggested that equal volumes of all gases contain the same number of molecules. This is called Avogadro's hypothesis. This idea is approximately true as long as the pressure is not too high or the temperature too low. It is convenient to measure volumes of gases at room temperature and pressure, or 20 Celsius degree with 1 atmosphere. Here, RTP is short for room temperature and pressure. So at room temperature and pressure, 1 mole of any gas has a volume of 24.0 cubic decimeters. So, 24.0 cubic decimeters of carbon dioxide and 24.0 cubic decimeters of hydrogen both contain 1 mole of gas molecules. We can use the molar gas volume of 24.0 cubic decimeters at RTP to find 1. The volume of a given mass or number of moles of gas. 2. The mass or number of moles of a given volume of gas. Now, let us see an example to show how to calculate the questions related to gas volume. Calculate the mass of methane, present in 120 cubic centimeters of methane. The relative molecular mass is given as 40.0. The first step is to change cubic centimeters to cubic decimeters. Therefore, the volume of methane is 0.120 cubic decimeters. Then moles of methane equal to volume divided by 24.0. And the mass of methane equal to product of moles and molar mass. At last, there are 0.080 grams of methane. We can use the ratio of reacting volumes of gases to deduce the stoichiometry of a reaction. According to Avogadro's hypothesis, equal volumes of gases contain equal numbers of molecules and therefore equal numbers of moles of gases. We can extend this idea to experiments involving combustion data of hydrocarbons. The example below shows how the formula of propane and the stoichiometry of the equation can be deduced. Propane is a hydrocarbon, which is a compound of carbon and hydrogen only. When 50 cubic centimeters of propane reacts exactly with 250 cubic centimeters of oxygen, 150 cubic centimeters of carbon dioxide is formed. So, the first step is to write down the chemical equation as much as possible. And then, we get the ratio of moles based on the volumes of substances. As 1 mole of propane produces 3 moles of carbon dioxide, there must be 3 moles of carbon atoms in 1 mole of propane. The 5 moles of oxygen molecules are used to react with both the carbon and the hydrogen in the propane. 3 moles of these oxygen molecules have been used in forming carbon dioxide. So 5 minus 3 equal to 2. 2 moles of oxygen molecules must be used in reacting with the hydrogen to form water. There are 4 moles of atoms in 2 moles of oxygen molecules. So there must be 4 moles of water formed. Therefore, there must be 8 hydrogen atoms in 1 molecule of propane. Now, we can get the chemical formula for propane. As a summary, we have covered the details in 1, using the molar gas volume, 2, gas volumes and stoichiometry. That is all for today. Have a nice day and bye.